Hi my dear students, in the previous videos we discussed the definition of the matrix, we discussed what is rows and what is columns, we discussed, and also we discussed how to write the order of the any given matrix. So how will you write the order of the given any matrix? That is the number of rows and the number of columns will give us the order of the given matrix, and based on that some examples also we discussed, and also we discussed one note, the main note, that is important note. So what is that? If we have the matrix of the order m cross n, then that matrix will contain mn elements. That note we discussed. So based on this we solved some examples, so that is exercise questions 3.1. In the previous videos we discussed, and today's class we are going to discuss the types of the matrices. So before studying the types of the matrices, so I am going to recall the things, that is in the first video only I discussed. If we have the matrix, if in general, so in general, if I have the matrix of order m cross n, and this is the general notation. So the matrix in general, a matrix we will write it as, if the order is m cross n, then we will write it as A is equals to Aij. So this is the compressed form, and this is the compressed form. But I told also how to write another one way. So that is A is equals to, we discussed the element here it means that m cross n means what it indicates? It indicates that a matrix has m rows and n columns. So I'll write that one. So m indicates what it indicates? M indicates the rows and n indicates the columns. And so my dear students, just I am writing. In general, how will you write? That is A11. And the first element of the, in general I am writing the elements. A11 means what? First row, first column. So A11, A12, A13 up to so on, and here it is up to so on A1J. Some middle term I am taking here, it is J columns. This is A11 means what? First row, first column. First row, second column. First row, third column, up to so on some middle term, first row, jth column, and the last element, lastly, how many columns are there? N columns. So this is jth column, this is third column, this is second column, this is first column. So therefore this is A1n. A1n means what it indicates? A1n means first row, nth column element. So here I am writing the matrix of the order m cross n. M cross n means what? N columns must be there. So therefore I am writing A1n. And my dear students, next element I should write it as A21. A21 means second row, first column. A22, A23 up to so on A2J. Second row, jth column. Some middle term. It may be the 100th or it may be the 1000. Whatever may be. That is depending upon the given context. Is it? So therefore, here how many columns must be there? N columns must be there. So therefore 2j, and lastly the last element of this row is 2n. Here it is. Because second row, last column, that is nth column. And next my dear students, third row, first column, A31, A32, A33 up to so on A3j. And up to so on, here it is a third row, nth column, A3n. And next my dear students, I'll write some middle term here. So it's not necessary to write so on up to how many you are interested, that much back dashes. No, don't put. If you write the 3, then that's enough. That is understood that some continued terms are there like that. So keep on going. You should not put the dashes. Is it? So next and lastly here it is. I am taking here it is. This is third row, and next I will take it as how many? Here it is. Some middle row I will take. How I take here it is. Similarly I took here it is jth column. Is it? Some middle column I am taking it as jth. Similarly in the row wise I will take it here it is I1. Here it is. Some middle row I am taking. Ith row I am taking AI1. AI2, AI3 up to so on Aij, and up to so on Ai n. Ith row, nth column. Some middle row I took. And last here it is up to so on. Here up to so on. The last how many rows must be there? M rows must be there. First row, second row, third row, some middle ith row, ith row, and next here it is M. Last must be AM1, AM2, AM3 up to so on, jth column, mth row, and last element is AMN, mth row, nth column. So therefore AMN is the last element. So my dear students, if a matrix is of the order m cross n, then we'll write the we will write the elements like this. Either we can write like this or we can write like this. So this is the compressed form of this. Is it? So this we discussed in the first day of my video only. I discussed this. So just I am recalling the things. I am recalling all this because if we understand correctly this information, then we can discuss the types of the matrices. For that purpose I am explaining once again. Is it? And now here it is. See here students. This is A11, A22, A33, Aij. Here it is. All these here, all these elements we can. So before that, if I have the rectangle, if I have the any rectangle, then this we can call it as the, generally we know in the studied in the earlier classes, we can call that as the diagonal line. Is it? So diagonal places, that we can call it as the diagonal. Likewise, in the matrices also, my dear students, this A11, A22, A33, Aij up to so on. So whatever elements are there, that is A11, A22, A33 up to so on, all these elements we can call it as the diagonal elements. Diagonal elements. So my dear students, in the matrix of the order m cross n, whatever elements are there, that is A11, A22, A33, such elements we can call it as the diagonal elements, and remaining whatever elements are there, this is the, and here it is the on the diagonal line, whatever elements lies, this line, the diagonal elements where lying, that line we can call it as the principal, that we can call it as the principal diagonal. We can principal diagonal we can call that line, we can call it as the principal diagonal, we may call here it is. Is it? So this information we should need here it is, or else leading diagonal also we can call it this. This whatever diagonal elements are lying, that line we can call it as the, that line constitute the principal diagonal we can call, or we can call it as the leading diagonal we can call. And here it is, the remaining elements except this A11, A22, A33, above this value, these elements and below these elements, these all we can call it as the non-diagonal elements. So diagonal elements, what are diagonal elements? A11, A22, A33, these are all the diagonal elements. The diagonal elements were lying, those line, that line we can call it as the principal diagonal, or we can call it as the leading diagonal we can call here it is. And next, the remaining elements I'll call it as the non-diagonal elements we can call, or non-principal diagonal elements we can call here. So this is the information we should know. And please remember students, if I write Aij is equals to Aij, if I equals to j means A is equals to Aij, if I is equals to j means what it indicates? A matrix A is equals to Aij. If I is equals to j means I is equals to j. I is equals to j only case here in these places. 1 is equals to I value and j value are same. That is 2, 2 here it is I and j values are same. A, 3, 3 I and j values are same. So therefore, my dear students, here Aij we can call it as Aij. If I is equals to j means what it indicates? It indicates that these are the principal diagonal elements, or diagonal elements we can call here it is. This we can call it as the diagonal elements or principal diagonal elements, we can call it as, or generally we will call it as the diagonal elements. I'll write once. So this we can call it as the diagonal elements, is it? And next, my dear students, the if I write here it is, or if I write A is equals to Aij if I is greater than J. If I is greater than J means what it indicates? I is greater than J means this value, I is greater than J. So generally we know that I indicates the row and J indicates the column. Aij, A is equals to Aij if I is greater than J means which elements? It is here, it is this element. I value is greater than J. Here I value is 2, J value is 1, I value is 3 and J value is 1. So here it is, if the AI is equals to Aij, if I value is greater than J means what it indicates? This indicates that the elements below the principal diagonal. So this we can call it as the below the principal diagonal. Short I am writing principal diagonal elements. So this indicates that A is equals to Aij if I is greater than J means what it indicates? It indicates that these are the elements which lies below the principal diagonal, that we can call here this. And these are the, just in short, mathematically I am writing in short like this. And next here this, if I write, this all information I am going to use while explaining the types of the matrices. So therefore, if I write, my dear students, if I write A is equals to Aij if I value is less than J. I value is less than J means what are the elements? I value is less than J. Here you can observe here it is. Here I value is 1, J value is 2. It means that I is less than J. Is it? And next here also I is less than J. I is less than J. Here I value is J and I value is 2 and J value is 3. It means that I value is less than 3. You can observe here it is, any number you can take above the principal diagonal. This is your principal diagonal. So above the principal diagonal, always the elements will be in this form. I value is less than J. That is A is equals to Aij. In the further, if I write further, while or else next, if I write A is equals to Aij, if I is less than J means you should understood that the elements which lies above the principal diagonal. So in future, if I write A is equals to Aij means what should you think? You should think that yes, these are the elements which lies above the diagonal elements. If I write Aij is equals to Aij if I is greater than J means what you should think? Yes, these elements are below the principal diagonal, like this you should think. So these are all the information you should require while solving the problems as well as while discussing the types of the matrices. In that case, these are all conditions we should remember or we should know already. Also already we should understood these things, then only we can discuss the types of the matrices. Is it clear? I hope you understood. I'll explain once in Kannada. So students, ನಾವು ಆಲ್ರೆಡಿ ಡೆಫಿನೇಷನ್ ಹೇಳುವಾಗ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಡೆಫಿನೇಷನ್ ಹೇಳುವಾಗ ನಾನು ನಿಮ್ಗೆ ಏನು ಹೇಳಿದ್ದೆ, ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಜನರಲಿ ನಾವು ಯಾವ ಲೆಟರ್ ಇಂದ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ದೆ, ಕ್ಯಾಪಿಟಲ್ ಲೆಟರ್ ಎ ಇಂದ ಯೂಸ್ ಮಾಡ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ದೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ನಾನು ಬರ್ತೀನಿ Aij ಅನ್ನೋದು ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೈತಿ? ಎಲಿಮೆಂಟ್ಸ್, ಇನ್ ಜನರಲ್ ಎಲಿಮೆಂಟ್ಸ್. ಸೊ Ij ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೈತಿ ಅಂತ ಹೇಳಿದ್ರೆ I means rows, ಎಷ್ಟು ಆರ್ಡರ್, I means ith row. ಸೊ ಆಮೇಲೆ J indicates, J ಏನ್ ಇಂಡಿಕೇಶನ್ ನೊಟೇಷನ್ ತೋರಿಸುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಎಷ್ಟು ಕಾಲಮ್, jth ಅಂದ್ರೆ jth ಕಾಲಮ್, ಕಾಲಮ್ಸ್ ಎಷ್ಟಿದಾವ, ರೋಸ್ ಎಷ್ಟಿದಾವ ಇಂಡಿಕೇಟ್ಸ್ ಮಾಡ್ತದೆ Aij. and here this is the element A11 or Aij means what? Aij ಅಂತ ಹೇಳಿದ್ರೆ ith row ಮತ್ತೆ jth ಕಾಲಮ್. Aij means ith row and jth ಕಾಲಮ್, jth ಎಲಿಮೆಂಟ್ ಯಾವುದು ಅನ್ನೋದು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಾ ಇರ್ತದೆ Aij ಅನ್ನೋದು. that we discussed in the first class. ಸೊ ಆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಆಮೇಲೆ m cross n ಇಲ್ಲಿ ಬರೆದ್ರೆ ಏನು, m cross n ಬರೆದ್ರೆ m ರೋಸ್ ಇದಾವೆ, ಆಮೇಲೆ n ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್ ಇದಾವೆ ಅಂತ ಹೇಳಿ ನಮಗೆ ಗೊತ್ತಿತ್ತು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಜನರಲ್ notation of the matrix. So either we can write like this or another one way I can write here it is like this. So that means that here it is how we are writing this one a11. So ಇದನ್ನ ಹೇಗೆ ಬರಿತಾ ಇದ್ದೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ a11 ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಫಸ್ಟ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಅನ್ನ a11 ಅಂತ ಬರಿತೇನೆ. ಸೊ a11 a ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ 1 ಅಂತ ಕರೀತೇವೆ. ಸೊ a ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ 1 ಅಂತ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಅದನ್ನ a11, ಫಸ್ಟ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ a12, ಫಸ್ಟ್ ರೋ ಥರ್ಡ್ ಕಾಲಮ್ a13 ಲೈಕ್ ದಿಸ್. ಆಮೇಲೆ ನಂತರ ಸಮ್ ಮಿಡಲ್ ಟರ್ಮ್. So it may be the here it is ಇದು ಥರ್ಡ್ ಕಾಲಮ್ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಫಸ್ಟ್ ಕಾಲಮ್ ಸಮ್ ಮಿಡಲ್ ಕಾಲಮ್ ಅನ್ನು ನಾನು jth ಕಾಲಮ್ ಅಂತ ತಗೊಳ್ತೇನೆ. ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ಲಿ ನನ್ನ ಹತ್ರ ಎಷ್ಟು ರೋ ಎಷ್ಟು ಕಾಲಮ್ಸ್ ಇರಬೇಕಿಲ್ಲ n ಕಾಲಮ್ಸ್ ಇರಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ a1n ಲಾಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಲಾಸ್ಟ್ ಕಾಲಮ್ should be 1n. So therefore I am writing a1n. Is it? And now my dear students, how many rows must be there? There must be m rows must be there. So therefore I am writing here it is. This is first row, second row, third row, I mean some middle row I am taking, that is ith row, and after taking lastly am1 I am taking. I am taking, this means that am1 means what it indicates, am1 means mth row. ಸೊ ಇಲ್ಲಿ ಏನು ತಗೊಳ್ತಾ ಇದ್ದಾನೆ mth row ತಗೊಳ್ತಾ ಇದ್ದಾನೆ. mth row ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಯಾಕೆ mth row ನೇ ತಗೊಳ್ತಾ ಇದ್ದಾನೆ ಇದು ಜನರಲ್ ಆಗಿ ಬರೀತಾ ಇರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಆಮೇಲೆ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು m ರೋಸ್ ಇದಾವೆ n ಕಾಲಮ್ಸ್ ಇರೋದ್ರಿಂದ ನಾನು ಏನು ತಗೊಳ್ತಾ ಇದ್ದೇನೆ m ಲಾಸ್ಟ್ಲಿ mth row ಆಮೇಲೆ nth ಕಾಲಮ್. ಸೊ therefore last element is amn. So this is a general notations. So more if you want more knowledge about this means please refer my first video. ಆ ವಿಡಿಯೋದಲ್ಲಿ ಆಲ್ರೆಡಿ ಇದನ್ನ ಬರೆದಾಗಿದೆ. ಸೊ ಈಗ ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ ಫ್ಯೂಚರ್ ಅಲ್ಲಿ ನಾನು ಏನು ಯೂಸ್ ಮಾಡ್ತೇನೆ. ಸೊ a is equals to aij ಅಂತ ಬರೆದ್ರೆ ಆರ್ ಎಲ್ಸ್ ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನಂತ ಹೇಳಿದ್ರೆ ಸೊ ನಮಗೆ ನಾರ್ಮಲಿ ನಾವು ಕನ್ನಡದಲ್ಲಿ ಇದನ್ನ ಕರ್ಣ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಯಾವುದೇ ಒಂದು ರೆಕ್ಟಾಂಗಲ್ ತಗೊಂಡಿದ್ದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ ದ ರೆಕ್ಟಾಂಗಲ್ ಒಂದು ರೆಕ್ಟಾಂಗಲ್ ಅಲ್ಲಿ ಈ ಲೈನ್ ಅಲ್ಲಿ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ತಾವೆ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ ಕರ್ಣ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಕನ್ನಡ ಒಳಗೆ ಕರ್ಣ ಅಂತ ಕರಿತಿರ್ತೇವೆ. ಸೊ ಅಥವಾ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಈ ಡಯಾಗೋನಲ್ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಡಯಾಗೋನಲ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ತಾವೆ ಅದಕ್ಕೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಆರ್ ಎಲ್ಸ್ ಇಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ನಾವು ಹೇಳ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ ಏನಂತ ಹೇಳಿದ್ರೆ a11 a22 a33 ಈ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ ಅಥವಾ here it is diagonal elements ಅಂತ ಕರಿತೇವೆ. ಆರ್ ಎಲ್ಸ್ we can call it as the just we'll write the diagonal elements and then ಮತ್ತೆ ಈ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನ್ ಲೈ ಆಗ್ತಾವಲ್ಲ ಆ ಲೈನ್ ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ ಆ ಲೈನ್ ಅಲ್ಲಿ ಈ ಲೈನ್ ಅಲ್ಲಿ ಏನು ಬರ್ತೈತಿ ಅಥವಾ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ಬರಿತೇವೆ ಆ ಲೈನ್ ಅನ್ನ ನಾವು ಏನ್ ಕರಿತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ. ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ ಅಥವಾ ನಾವು ಅದನ್ನ ಏನು ಕರಿತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ ಲೀಡಿಂಗ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಥವಾ ಲೀಡಿಂಗ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಥವಾ ಲೀಡಿಂಗ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದು a11 a22 a33 ಅಪ್ ಟು ಸೊ ಆನ್ ವಾಟ್ ಎವರ್ ಎಲಿಮೆಂಟ್ಸ್ ಈ ರೀತಿ ಎಲಿಮೆಂಟ್ಸ್ ಏನ್ ಲೈ ಆಗ್ತಾ ಇದಾವೆ ಸೊ ಆ ಎಲ್ಲಾ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಲೈನ್ ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ ಡಯಾಗೋನಲ್ ದಟ್ ವಿ ಕ್ಯಾನ್ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೇವೆ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ ಅಥವಾ ಲೀಡಿಂಗ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಇಷ್ಟಾದ್ಮೇಲೆ ಸಪೋಸ್ ನಾನು ಜನರಲ್ ಆಗಿ ಶಾರ್ಟ್ ಆಗಿ ಹೆಂಗ್ ಬರಿತೇನೆ a is equals to aij if I is equals to j ಅಂತ ಹೇಳಿದ್ರೆ if aij a is equals to aij if I is equals to j ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಇರುತ್ತೆ ತಿಳ್ಕೋಬೇಕು ನೀವು ಅಂತ ಹೇಳಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡುವಾಗ a is equals to aij if I is equals to j ಅಂತ ಕರೆದ್ರೆ ನೀವೇನ್ ತಿಳ್ಕೊಳ್ಬೇಕು ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇದೇನಲ್ಲ ಇದು ಬೇರೆ ಏನಲ್ಲ ಇದಂದ್ರೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತಾನೆ ತಿಳ್ಕೊಳ್ಬೇಕು. ಯಾಕೆ ಇದಂದ್ರೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ a11 ಇದೆ ಇಲ್ಲಿ a22 ಇದೆ ಇಲ್ಲಿ a33 ಇದೆ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ ದಟ್ I ಮತ್ತೆ j ವ್ಯಾಲ್ಯೂ ಈಕ್ವಲ್ ಇರತಕ್ಕಂತ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ aij if I is equals to j ರೋ ಮತ್ತೆ ಕಾಲಮ್ ಸೇಮ್ ಇರಬೇಕು. ಫಸ್ಟ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಅದನ್ನ a11 ಅಂತ ಬರೀತಿದ್ದೇನೆ. ಸೆಕೆಂಡ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ a22 ಅಂತ ಬರೀತೇನೆ. ಥರ್ಡ್ ರೋ ಥರ್ಡ್ ಕಾಲಮ್ a33 ಅಂತ ಬರೀತೇನೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ aij if I is equals to j ಆಗ್ತಾ ಇದ್ರೆ ರೋ ಮತ್ತೆ ಕಾಲಮ್ ಎರಡು ಸೇಮ್ ಇದ್ದಾಗ ಆಬ್ವಿಯಸ್ಲಿ ಅದೇನಾಗಿರ್ತೈತಿ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿರ್ತೈತಿ. Is it? Next, my dear students, if I write a is equals to aij if I value is greater than j, a is equals to aij if I value is greater than j means what it indicates I value is greater than j ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಫಸ್ಟ್ ಇಲ್ಲಿ I value greater than j it means that ರೋ ಏನಾಗಿರಬೇಕು ಕಾಲಮ್ ಕಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. ಸೊ ರೋ ದ ವ್ಯಾಲ್ಯೂ 2 here it is 2 is greater than 1 and here it is 3 is greater than 1 3 is greater than 1 3 is greater than 2. ಸೊ therefore I ಏನಾಗಿದೆ ಇಲ್ಲಿ j ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ. ಸೊ I ವ್ಯಾಲ್ಯೂ ಏನಾದ್ರು j ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಅವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಿದಾವ ನೋಡ್ರಿ 2 ಇದು I ವ್ಯಾಲ್ಯೂ 2 ಐತಿ j ವ್ಯಾಲ್ಯೂ 1 ಐತಿ. ಸೊ 2 ಇದು 1 ಗಿಂತ ಜಾಸ್ತಿ ಐತಿ 3 1 ಗಿನ ಜಾಸ್ತಿ ಐತಿ, 3 2 ಗಿನ ಜಾಸ್ತಿ ಐತಿ. ಸೊ ಈ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಕೆಳಗಿನಿಂದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಏನೈತಿ, ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಬಿಟ್ಟು ಕೆಳಗೆ ಏನು ಎಲಿಮೆಂಟ್ಸ್ ಬರ್ತಾವು ಆ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿದಾವ ಅಂತ ಹೇಳಿದ್ರೆ below the principal diagonals irtavu. It means that if I value is greater than j, these elements are possible only if they are this is only possible only if the elements lies below the principal diagonal. Principal diagonal ಕೆಳಗಡೆ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ ಏನಾಗಿರ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಂಡೀಷನ್ ಅನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾ ಇರ್ತಾವ. ಅದಕ್ಕೋಸ್ಕರ a is equals to aij if I is greater than j ಅಂತ ಹೇಳಿದ್ರೆ ನೀವೇನ್ ತಿಳ್ಕೊಬೇಕಂತ ಹೇಳಿದ್ರೆ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಗಿಂತ ಕಡಿಮೆ ಯಾವ ಇದಾವೆ, ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಗಿಂತ ಕೆಳಗೆ ಯಾವ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಇದಾವು ಅವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿರ್ತಾವು aij if I value is greater than j ಅನ್ನೋ ಕಂಡೀಷನ್ ಅನ್ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇರ್ತವೆ. ಸಿಮಿಲರ್ಲಿ if I value is less than j, I value is less than j ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಕಾಲಮ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ, ಕಾಲಮ್ ಎಲಿಮೆಂಟ್ ಕಾಲಮ್ ಜಾಸ್ತಿ ಇರಬೇಕು, ರೋ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಅಬೌವ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಇಲ್ಲಿ I value 1 ಐತಿ, j value 2 ಇದೆ. So I value 1 ಇದೆ, j value 3 ಇದೆ. It means that j value is greater than I value. So 1 ಗಿನ 2 ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದೆ, 1 ಗಿನ 3 ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದೆ, 2 ಗಿನ 3 ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ನಾವು ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು I ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತಾ ಇದೆ, j ವ್ಯಾಲ್ಯೂ ಗಿನ ಕಡಿಮೆ ಇದೆ. I ವ್ಯಾಲ್ಯೂ j ವ್ಯಾಲ್ಯೂ ಗಿನ I ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇದೆ. I is less than j. ಅದಕ್ಕೋಸ್ಕರ a is equals to aij if I is less than j ಅಂತ ಬರೆದ್ರೆ ನೀವು ಏನು ಅನ್ಕೋಬೇಕು ಮೀನಿಂಗ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಆಗ್ತಾ ಇದಾವೆ, these are the elements lies above the principal diagonal. ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಗಿಂತ ಮೇಲೆ ಏನೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಇದಾವೆ ಅವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಏನ್ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾವ a is equals to aij if I is less than j. ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆದ್ರೆ ನೀವೇನ್ ತಿಳ್ಕೋಬೇಕು, ಎಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಿವೆ ಅಂತ ಹೇಳಿದ್ರೆ above the principal diagonal, ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಗಿಂತ ಮೇಲ್ಗಡೆ ಇರುವಂತ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳಿ ನೀವು ತಿಳ್ಕೋಬೇಕು. ಸೊ ಇದೆಲ್ಲ ಇನ್ಫಾರ್ಮೇಶನ್ ಎದಕ್ಕೆ ಹೇಳಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮಗೆ ಜಸ್ಟ್ ವೈಲ್ ಡಿಸ್ಕಸಿಂಗ್ ಟೈಪ್ಸ್ ಆಫ್ ದ ಮ್ಯಾಟರ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಇಷ್ಟು ಡೀಪ್ ನಿಮಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಬೇಕು ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಬಟ್ ನಮಗೇನು ಮುಂದೆ ಫ್ಯೂಚರ್ ಅಲ್ಲಿ ಸಿಇಟಿ ಕ್ವಶನ್ಸ್ ಇರಲಿ ಅಥವಾ ಡೆಫಿನೇಷನ್ಸ್ ಅನ್ನ ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ನಮಗೆ ಇಷ್ಟು ಇನ್ಫಾರ್ಮೇಶನ್ ಗೊತ್ತಿರಬೇಕು. ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್. And next we will come to the point, that is types of the matrices. So my dear students, we discussed the definition of the matrices and order of the matrix, that all we discussed, and now we are going to discuss the next concept, that is types of the matrices. In that I am going to discuss the first one is the column matrix. So column matrix anta helidre normally we know what is columns and rows we know. So but still I discussed that what is meant by rows and column, but still once again I will repeat the things. So my dear students, if I wrote the any matrix 1 2 3 4, just I am taking one example to understand what is columns and what is rows. So my dear students, if I have this one matrix, in this matrix the horizontal line constitute the rows, and we discussed the vertical lines constitute the columns. So this information is very very important, because if you know the what is meant by columns and what is meant by rows, then only we can understand easily the types of the matrices. So these are all the basic things just to understand the types of matrices. For that reason I am explaining all this. Yes, my dear students, if I have any matrix here it is, so the horizontal line constitute the rows and the vertical line constitute the columns. So ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಅಡ್ಡ ಸಾಲುಗಳನ್ನು ನಾವೇನಂತ ಕರಿತೇವೆ, ರೋಸ್ ಅಂತ ಕರಿತೇವೆ. ಆಮೇಲೆ ವರ್ಟಿಕಲ್ ಲೈನ್ ಅನ್ನು ನಾವೇನಂತ ಕರಿತೇವೆ, ಕಾಲಮ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ವರ್ಟಿಕಲ್ ಅಂದ್ರೆ ಈ ರೀತಿ ಕಂಬ ಸಾಲು, ಆಮೇಲೆ ಹಾರಿಜಾಂಟಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ರೀತಿ ಇರೋದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ, ರೋಸ್, ಅಥವಾ ಈ ರೀತಿ ನಾವು ರೋಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ ಕನ್ನಡದಲ್ಲಿ ಅಡ್ಡ ಸಾಲುಗಳು. ಆಮೇಲೆ ಈ ರೀತಿ ವರ್ಟಿಕಲ್ ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ, ಕಾಲಮ್ಸ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಸೊ ಈ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೂಡ ನಾವು ಮುಂಚೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಆರ್ಡರ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ಡರ್ ಬರೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಹೇಗೆ ಬರೀಬೇಕು ನಾವು ಆರ್ಡರ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಎಷ್ಟು ಅಡ್ಡ ಸಾಲು ಇದಾವೆ ಅಂತ ನೋಡ್ಬೇಕು. ಸೊ ಹಿಯರ್ ಇಟ್ ಇಸ್, ಸೊ 1 2 ಎರಡು ಅಡ್ಡ ಸಾಲು ಇದಾವೆ. ನೆಕ್ಸ್ಟ್ ಯು ಶುಡ್ ರೈಟ್ ಲೈಕ್ ದಿಸ್, cross sign you should write, and how many columns, 1 2 columns are there. So therefore e matrix is order ಎಷ್ಟು ಅಂತ ಹೇಳಿದ್ರೆ 2 by 2. we should write it as 2 by 2. 2 cross 2 ಅಂತ ಓದುವಾಗಿಲ್ಲ, ನಾವೇನಂತ ಓದಬೇಕು, 2 by 2 ಅಂತ ಓದಬೇಕು. 2 by 2 ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು? ಸೊ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ 2 ರೋಸ್ ಇದಾವೆ, 2 ಕಾಲಮ್ಸ್ ಇದಾವೆ ಅಂತ ಮೀನಿಂಗ್ ಕೊಡ್ತದೆ. ದಟ್ ಈಸ್ ದ ಆರ್ಡರ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್. Is it? So these are all information we discussed. And now I am going to discuss what is mean by column matrix. So my dear students, column matrix means a matrix having, so the definition is a matrix, so the definition is a matrix having only one column is called column matrix. Is it, my dear students? So definition is very simple. What is that? A matrix having only one column is called as column matrix. ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಒಂದೇ ಕಾಲಮ್ ಇರ್ತೈತೋ ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ? ಕಾಲಮ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದ ಎಕ್ಸಾಂಪಲ್ A is equals to 1 2 3. So this is the example for the column matrix. Why it is column matrix? Because only one column is there. ಒಂದೇ ಏನಾಗಿದೆ ಇಲ್ಲಿ ಕಂಬ ಸಾಲು ಇದೆ. ಸೊ ಒಂದೇ ಕಂಬ ಸಾಲು ಇರೋದ್ರಿಂದ ಇದನ್ನ ಏನಂತ ಕರಿತೇನೆ? ಕಾಲಮ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಇನ್ ಇಂಗ್ಲಿಷ್ a matrix having only one column is called as column matrix. Is it? And next, my dear students, next I will take another one example. You can take 1 2. So this is also example for the column matrix. Why? Because here also we have the only one column. So why here it is one column is there. And what is the order of this matrix? First I will write the order of this matrix. So what is the order of this matrix? Order of this matrix is, how many rows are there? 1 2 3. 3 rows are there. By how many columns are there? 1 columns. Is it? So order of this matrix is 3 cross 1. Next, my dear friends, what is the order of this matrix? How many rows are there? 1 2. 2 rows are there. Cross, that is by how many columns are there? How many rows are there? 2 rows are there. How many columns are there? Only 1 column is there. So therefore order of this matrix is 2 cross 1. So as you observing here, these are the examples. Here see it is. In this particular example, what is the order of the matrix? 3 cross 1. And next here is in this example, what is the order of the matrix? 2 cross 1. So therefore you can observe here in the column matrix in general a column matrix will be like this. In general, we will write the order of the column matrix is always m cross 1. Why m cross 1? Here it is. Here the only possibilities is here the rows may change. Here in this case 3 rows are there. In this case 2 rows are there. But always the column is 1 only. Here also column is 1. Here also column is 1. So therefore in general, if the matrix is a column matrix, then the matrix order is always m cross 1. This is the matrix I am taking it is generally. If the matrix here is m rows are there, only the rows may change. That is depending upon the situation or depending upon the given context. But the row always column must be 1 only. It may changes the rows. So therefore I am writing in general the column matrix order is m cross 1. So therefore these are the examples for the column matrix. So what is the definition here? It is a matrix having only one column is called as the column matrix. And next, my dear students, next I am going to discuss the second type is row matrix. So it is also simple. So as we discussed the definition column matrix, what I told, column matrix means a matrix having only one column is called as column matrix. And next here is row matrix means, yes, row matrix means a matrix which has only one row is called as row matrix. Simple. So a matrix having only one, only one. I think these all information you should remember. If you want means you can pause the video and you can write this information, because this information I am going to use in future. So please remember students, this information, please try to remember this, or else you can write in your notes. Pause the video and write this information. As of now I am erasing this one due to the space. Yes. Yes, my dear students, here a matrix having only one row is called row matrix. Is called row matrix. And here it is examples you can take here. A is equals to, or else take it as x, y, z, whatever your wish. So 1, 2, 3, 4. So here it is a matrix having only one row. So it is, how many rows are there? Only one row is there. ಎಷ್ಟು ಅಡ್ಡ ಸಾಲುಗಳಿದಾವೆ ಇಲ್ಲಿ? ಒಂದೇ ಅಡ್ಡ ಸಾಲು ಇದೆ. But how many columns are there, my dear students? 1, 2, 3, 4. So therefore, how many rows? 1. And what is the order of this this matrix? Here it is. How many rows? Here it is. One row. And how many columns here it is? 1, 2, 3, 4. 4 columns are there. Is it? And my dear students, another one example you can take x. This is the example for the x, and next you can take the example, another one example I am taking y is equals to 1, 2, 3. So this is also example for the row matrix, because how many rows are there? One row is there. By how many columns? 1, 2, 3. 3 columns are there. So therefore these are all the examples for the row matrix, because this is the matrix here. In this matrix, this contains only one row, therefore this is the row matrix. This is also row matrix because it contains the only one row. So therefore a matrix having only one row is called as row matrix. And my dear students, in general here also you can take the order of the matrix. The row matrix is denoted by B is equals to Bij. So don't be confused. Here I took A is equals to Aij, and here I am getting Bij. Don't be confused. Just this is the notation. Here also you can take Aij or X, whatever you can take. Just it is notation. So therefore B is equals to Bij I am taking. So this is in this case. So what is the order of the matrix? In the row matrix, the order will be always in the form of, here it is 1 cross n, because here it is always, here observe here one row, this row will be 1, and here also one row is there, so therefore 1. And next columns may differ. Here 1, 2, 3, 4, 4 columns are there. In this case 1, 2, 3, 3 columns are there. So therefore this is the variable. It means that it can change the variable. That is it can change the columns, number of columns, but the row must be always one only. So this is the constant, it must be one only. And next this may changes, the columns may change, that is depending upon the situation or depending upon the context. So in which case you are studying the problem, in that case you can take the columns, is it? But always the row matrix, always row must be 1, so therefore this is fixed. And in the column matrix, the column must be fixed. So therefore here I am writing the order m cross n, and here I am writing the order 1 cross n. This is a general notation, but the definition is, if a matrix, here it is a matrix having one column is called as column matrix, a matrix having only one row is called as row matrix. So this is the first type, here it is, that is column matrix, and this is row matrix. And next I am going to discuss the third one is, my dear students, that is square matrix. Square matrix. So simple, here it is. Square matrix means, my dear students, in a matrix, if the generally we know how to write the order of the matrix, or how will you write the order of the matrix? In a row, if we have the number of rows here, number of rows cross, that is number of rows by number of columns, will gives us the order of the matrix. Now I am discussing the definition, that is square matrix. So square matrix is nothing but a matrix having the number of rows equals to number of columns, then such a matrix we can call it as the square matrix. A matrix in which number of rows equals to the number of columns. This we can call it as the square matrix. A matrix in which number of rows is equals to number of columns, that is m is equals to n. A matrix in which number of rows is equals to number of columns, then such a matrix we can call it as the square matrix. And example you can take, A is equals to, I will take here it is 1 2 3 4 5 6 7 8 9. Yes, my dear students, please tell me the order of this matrix. What is the order of this matrix? Yes, yes, right. The order of the matrix is 1 2 3 cross 1 2 3. So therefore the order of the matrix is 3 cross 3. Why it is 3 cross 3? Order of the matrix is nothing but the number of rows. ಎಷ್ಟು order ಸಾಲು 1 2 3 number of rows by 1 2 3 number of columns. So 3 cross 3. The order of this matrix is 3 cross 3. So therefore this is the example for the square matrix. Why it is example for the square matrix? Square matrix means the number of rows must be equals to the number of columns. The number of rows is 3 and the number of columns is 3. So therefore this is satisfying this condition. So therefore this is the example for the square matrix. So square matrix means what? A matrix is said to be square matrix if number of rows is equals to number of columns. Then in such a matrix we can call it as the square matrix. This is the one example for the square matrix. And you can take another one example 1 2 3 4. So this is also example for the square matrix, my dear students, because 1 2 rows are there, 2 columns are there. So therefore this is also perfect example for the square matrix. And next we are going to discuss what is mean by the diagonal matrix. Yes, and before that, in this matrix, square matrix, generally we will write the order of the matrix, that is A is equals to Aij of order n we can write. So generally we can write A is equals to Aij of order n. Of order n, we are, instead of writing m cross n, I am writing of order n only, because of order n means what it indicates? Both rows and columns are equal. In the square matrix, rows and columns are equal. So instead of saying the here, before that I will explain in this particular example. In this example, instead of saying, so here it is, this is the matrix of order 3 cross 3. Already in the square matrix both rows and columns are equal. So therefore instead of telling 3 cross 3, I will tell only once 3. So this is the matrix of order 3. So then you should understood that. So yes, it is a square matrix. So therefore he is taking the only once the order of the matrix. That is, he is saying like the matrix is, this is the matrix of order 3. So if I tell like this, then you should understood that this is the square matrix whose order is 3. It means that 3 cross 3. Instead of saying this is the matrix of order 3 cross 3, I'll tell or I'll write only once the value I'll take. That is, this is the matrix of order 3. Then you should understood that this is the square matrix of order 3 cross 3, like that. Is it? So therefore generally we will write A is equals to Aij of order n. Clear? I hope you understood. So square of the matrix means, so ಮಕ್ಕಳೇ square of the matrix ಅಂತ ಹೇಳಿದ್ರೆ ಏನು? Square of the matrix ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್ ಇರ್ತಿತ್ತೋ ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ? ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಆಮೇಲೆ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಜನರಲಿ ಹೆಂಗ್ ಬರಿತೇನೆ? A is equals to Aij of order n. ಯಾಕೆ ಆಫ್ ಆರ್ಡರ್ n ಅಂತ ಬರಿತೇನೆ? ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಇನ್ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಏನಾಗಿರ್ತೈತಿ? ರೋಸ್ ಮತ್ತೆ ಕಾಲಮ್ಸ್ ಎರಡು ಈಕ್ವಲ್ ಇರೋದ್ರಿಂದ m ಕ್ರಾಸ್ n ಬರೆಯೋದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗೋದು ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೋಸ್ಕರ ನಾನೇನ್ ಬರಿತೇನೆ? ಆಫ್ ದ ಆರ್ಡರ್ n. ಆಫ್ ದ ಆರ್ಡರ್ n ಅಂತ ಬರೆದರೆ ನೀವು ಏನನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು? ಎಸ್, ಎರಡು n ಕ್ರಾಸ್ n ಇದ್ದು ಅಥವಾ m ಕ್ರಾಸ್ n ಅಂತ ಇದ್ರೂ ಅದನ್ನ ಒಂದೇ ಸಾರಿ ಬರಿತೇನೆ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಇನ್ನೊಂದ್ಸರಿ ಯೂಸ್ ಮಾಡೋದು ಉಳಿಲಿ ಅಂತ ಹೇಳಿ. ಸೊ ಸುಮ್ಮನೆ ಕಾಂಪ್ಲಿಕೇಟ್ ಆಗೋಬೇಡ ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೋಸ್ಕರ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ A is equals to Aij of order n ಅಂತ ಹೇಳಿ ಜನರಲ್ ನೋಟೇಷನ್ ಇಂದ ಬರಿತೇವೆ. So next after this, my dear students, next ನಾವು fourth type ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಅದು ಯಾವ ಮೆಥಡ್, ಯಾವುದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ that is diagonal matrix. So fourth one, if you have any doubts please comment, we'll reply for that. If you have any doubts please try to comment. And next, fourth one, that is diagonal matrix. Yes, my dear students, already we discussed what is the meaning of the diagonal elements. So diagonal elements, what are the diagonal elements? A11, A22, A33, these are all the diagonal elements. So diagonal elements, we know, if we know the diagonal elements, then only we can understand the diagonal matrix. So my dear students, diagonal matrix means a square matrix. We should always take the square matrix. So what is the square matrix? Square matrix means number of rows must be equal to the number of columns. So therefore a square matrix in which all non-diagonal elements must be 0. So my dear students, in a square matrix in which all non-diagonal elements must be 0, then such a matrix we can call it as the diagonal matrix, and that is in the mathematical notation we can write A is equals to Aij is equals to, here it is, Aij equals to 0 if I not equals to j. If I not equals to j means what? Here my dear students, I equals to j means those are all the diagonal elements. I is not equals to j means here in this case I is lesser than j. In this case I is greater than j. So these are the below the principal diagonal and above the principal diagonal. Those all elements are in such a case all the condition there, that the condition is I is not equals to j. My dear students, please see here, A is equals to Aij equals to 0 means what it indicates? If I not equals to j means. So below the principal diagonal and above the principal diagonal, all the elements 0. It means that A is equals to Aij equals to 0. If I is not equals to j means what it indicates? I not equals to j. Except this principal diagonal, in remaining all cases I value is not equals to j. That is all the non-diagonal elements. So these are the diagonal elements, and except these elements, principal diagonal, whatever remaining elements are there, whether it may be the above the principal diagonal or below the principal diagonal, all elements must be 0. I am not talking about the diagonal elements, whatever it may be, but my question is, or my condition is that above the principal diagonal and below the principal diagonal all the elements must be 0. That only I write in the form of here, A is equals to Aij equals to 0 if I is not equals to j. I am not discussing about I is equals to j, whatever may be the elements here, it may be 0 or 1, whatever may be, but only the condition is above the principal diagonal and below the principal diagonal the elements must be 0. So that is a square matrix in which all non-diagonal elements must be 0. All non-diagonal elements are 0. Non-diagonal means these all values and these all values, we can call it as the non-diagonal elements. I hope you understood what is meant by diagonal and non-diagonal. So that's why I discussed before discussing this condition. Before discussing the types of the matrices, I discussed this because you should know what are the diagonal elements and what are the non-diagonal elements. So again I will tell this one. So diagonal elements means A11, A22, A33. These are all we can call it as the diagonal elements, and remaining except these whatever elements are there, that all we can call it as the non-diagonal elements. So therefore my dear students, a matrix is said to be, sorry, you should not say a matrix, a square matrix you should always use. A square matrix in which all non-diagonal elements are 0, then such a matrix we can call it as the Aij. It means that except these diagonal elements, remaining all elements must be 0. But inside the principal diagonal, that is the diagonal elements may be 0, may not be 0. That I am not discussing. My condition is only that the non-diagonal elements must be 0. So whatever may be the diagonal elements, I am not worried about that. My condition is if the non-diagonal elements are 0, then that should be square matrix. A square matrix, if all non-diagonal elements are 0, then such a matrix is able that web matrix is able to call as the diagonal matrix. So you don't bother about these diagonal elements. If the given matrix is a square matrix and non-diagonal elements are 0, then you should conclude that yes, the given matrix is a diagonal matrix. Is it? So therefore, my dear students, the definition is a square matrix in which all and that should be all non-diagonal elements must be 0. Such a matrix we can call it as a diagonal matrix, and in notations we can write here it is, or that is A is equals to Aij equals to 0 if I is not equals to j. So and this we can call it as a diagonal matrix, and I'll take the example for this. The example for this matrix is, the diagonal matrix is 1 0 0 0 2 0 0 0 3. So therefore, is it example for the diagonal matrix? Will you tell? So what is it example for the diagonal matrix? Please think and tell. Of course, it's not possible to tell, but you can think yourself. Is it? Yes, my dear students. Yes, this is a diagonal matrix because all this is your diagonal. Is it? Because this I'll call it as the diagonal matrix because all non-diagonal elements. Is it? This is diagonal. These are all the diagonal elements. So all non-diagonal elements bit 2 non-diagonal elements are 0. So therefore, then you can call this, and obviously this is a square matrix. Is it a square matrix? This is a square matrix because 1 2 3 number of rows is equal to number of columns. Therefore, this is the square matrix and the non-diagonal elements are 0. Therefore, this is an example for the diagonal matrix. And let us take another one example, my dear students. B is equals to 0 0 0 0 0 0 0 0 0. Is it a diagonal matrix? Yes, you may be confused or you are not able to tell the answer for this, whether this is diagonal or not. Yes, my dear students, obviously this is also the diagonal matrix only, because don't bother about this diagonal elements. You should always think whether the given matrix is square matrix or not. Yes, 1 2 3 1 2 3. This is the square matrix, first condition. And what is the next condition you should satisfy? Non-diagonal elements must be 0. Yes, here the non-diagonal elements, these are all the non-diagonal elements. Whatever I wrote inside the black sketch, whatever using here, these elements are the non-diagonal elements. And next, my dear students, these are also my non-diagonal elements. This is the square matrix and non-diagonal elements are 0. So therefore, this is also a diagonal matrix only. I never said that diagonal elements, whether that is 0 or not. I am not saying, or I am not worrying about that. My condition is only that a matrix must be the square matrix and the non-diagonal elements must be 0. If these two conditions satisfies, then that's enough. That's enough for me, and then I can conclude that yes, the given matrix is a diagonal matrix. Clear? Yes. I'll take another one example. So here it is 1 0 0 0 2 0, and next 1 1 0 0 0. Is it a diagonal matrix, my dear students? Yes, you should check only two conditions, whether this is a 3 cross 3, that is sorry, whether it is a square matrix 1 2 3, 3 rows, 1 2 3, 3 columns. So therefore this is a matrix of order 3 cross 3. It means that number of rows is 3, number of columns is 3. Therefore this is a square matrix, because we know that square matrix means what? Square matrix means the number of rows must be equals to the number of columns. So therefore this is the square matrix. Now what I am doing, I am checking the given matrix is diagonal matrix or not. I am checking. To check the given matrix whether it is a diagonal or not, we should check the two conditions. The first condition is that whether the given matrix is square matrix or not. Obviously this is the square matrix because 3 rows are there. The number of rows is equal to number of columns. So therefore this is the square matrix. And the second condition is the non-diagonal elements. Non-diagonal, these are the 1 2 these are the diagonal elements, and the non-diagonal elements means these are the non-diagonal elements. My dear students, please remember, these are the non-diagonal elements. Yes, the non-diagonal elements are 0, and this is a square matrix. So therefore this is also example for the diagonal matrix. Is it? So like this you should think. And so therefore this is also called as a zero matrix, that we will discuss in the next. But as of now this is also example for the diagonal matrix, this is also example for the diagonal matrix, this is also example for the diagonal matrix. And please remember students, so this you can call it as a diagonal matrix, and it is denoted, generally we can denote here it is a diagonal matrix is equals to here it is diagonal 1 2 3. If I write diagonal 1 2 3, if I write means what you should understood. So this is a diagonal matrix. This notation, either we can write like this, in short we can write like this also, diagonal dij, you can write here this diag, diagonal 1 square bracket 1 2 3. If you write means this is nothing but this matrix only. So this is notation for the diagonal matrix. Yes, my dear students, so today's class we discuss the 4 types of matrices. That is the first is the column matrix, and next we discussed the what is mean by column matrix. So just I'll recall the things once. So the types of matrices, in that first one I discussed. So what is the definition or what is the column matrix? So column matrix means a matrix which has only one column. A matrix which has only one column is called as the column matrix. A matrix which has the only one row is called as the row matrix. And third one we discussed square matrix. So square matrix means what? If the number of rows is equal to number of columns, then such a matrix we can call it as the square matrix. And fourth one we discussed diagonal matrix. So diagonal matrix means what? A square matrix in which all non-diagonal elements are 0, then such a matrix we can call it as the diagonal matrix. So to check whether the matrix is diagonal or not, they should check two conditions. The first condition is whether the matrix is square matrix or not, first condition. And another one condition is that non-diagonal elements must be 0. And before if these two conditions satisfies, then you can say that is it that directly you should tell that yes, the given matrix is the diagonal matrix. Don't bother about this principal diagonal element or diagonal elements, because I never talked about the diagonal elements. Only my condition is in which all non-diagonal elements must be 0. I am not talking at all the diagonal elements, whether that is 0 1 whatever. I am not discussing about that. My intention or the given condition is only that whether the non-diagonal elements are 0 or not. Just you should check that one. So therefore these are all the example for the diagonal matrix. And normally the diagonal matrix notation will write like this: A is equal to diagonal 1 2 3. It means that the diagonal matrix having these are the elements in which lies in the diagonal places. Clear? Yes. We will discuss in the remaining types of the matrices. We will discuss in the next class. Sorry, I forgot to tell you this in Kannada. So ಮಕ್ಕಳೇ ನೋಡಿ ಇಲ್ಲಿ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಮತ್ತೆ ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್ ಎರಡೂ ಸೇಮ್ ಇದ್ದು ಅಂದ್ರೆ ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯಾವ್ದಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇರ್ತಾವೋ ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವೇನಂತ, ಆಮೇಲೆ ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರಬೇಕು. ಯಾವ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು 0 ಇರ್ತಾವೋ ಅಂತ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ, ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ, ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ನಾವು ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಕಂಡೀಷನ್ ಏನಾಗಿರ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಅಲ್ಲಿ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಬಿಟ್ಟು, ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಯಾವುದು, ಇದು ಕರ್ಣದ ಪ್ಲೇಸ್ ಅಲ್ಲಿ, ಕರ್ಣ ಅಂತ ಕರಿತೀವಿ ಡಯಾಗೋನಲ್, ದಟ್ ಇಸ್ ಡಯಾಗೋನಲ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್. ಆಲ್ರೆಡಿ ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದ್ದೇನೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನಂತ. A11 A22 A33 ಈ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ನಾವು ಏನಂತ ಕರಿತೇವೆ, ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ನಾನ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲವೋ ಅವಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ, ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಇದು ಕೂಡ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್. ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ ಇದು, ಮೇಲೆ ಮತ್ತೆ ಕೆಳಗಡೆ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ನಾವೇನಂತ ಕರಿತೇವೆ, ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ನಾವು ಎರಡು ಕಂಡೀಷನ್ ಅನ್ನು ಚೆಕ್ ಮಾಡಬೇಕು. ಮೊದಲನೇ ಕಂಡೀಷನ್ ಏನಂತ ಹೇಳಿದ್ರೆ ಅದು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಐತೆ ಇಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. ಸೊ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಐತೆ ಇಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು, ದ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್. ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಅಡ್ಡ ಸಾಲು ಇದಾವೋ ಅಷ್ಟೇ ಕಂಬ ಸಾಲುಗಳು ಇದ್ದರೆ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ಫಸ್ಟ್ ಕಂಡೀಷನ್, ಅದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ಬೋದು, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ ದಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಕಂಡೀಷನ್. ಆಮೇಲೆ ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ಏನ್ ಚೆಕ್ ಮಾಡಬೇಕು, ಸೊ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು 0 ಇದಾವೋ ಇಲ್ಲೋ ಅಂತ ಹೇಳಿ. ಅದು ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ತೀರಿ, ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ ಇದು ಮೇಲಿನ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇರಬೇಕು, ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಕೆಳಗಿನ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇದ್ರೆ ದೆನ್ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ, ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಕ್ಲಿಯರ್? ಅಂಡ್ ನೆವರ್ ಬಾದರ್, ನೀವು ಇದು ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ 0 ಆಯ್ತು 1 ಆಯ್ತು ಅದ್ರ ಬಗ್ಗೆ ನಮಗೆ ಭಯ ಬೇಡ. ನಮಗೆ ಏನು ಗೊತ್ತಿರಬೇಕು, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಐತೆ ಇಲ್ಲ ನೋಡ್ಕೊಳ್ಬೇಕು, ಆಮೇಲೆ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಬೋವ್ ಮತ್ತು ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಬಿಲೋ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಎರಡು ಏನಾಗಿರಬೇಕು, 0 0 ಇದ್ರೆ ಅವಾಗ ನಾವೇನಂತ ಹೇಳ್ಬೋದು, ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿ ಕರೀಬಹುದು. ಅಂಡ್ ರಿಮೈನಿಂಗ್ ಟೈಪ್ಸ್ ಆಫ್ ದ ಕ್ವಶನ್, ಉಳಿದ ಮುಂದಿನ ಟೈಪ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸಸ್ ಅನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ, ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಥ್ಯಾಂಕ್ ಯು.